solve the equation a over a minus 5 equals 3 plus 5 over a minus 5. So we have a rational equation here that we'd like to try and solve. Fractions are hard, right? So why don't we rewrite this rational equation into a polynomial equation, which is then easier to solve, right? We know how to solve a polynomial equation using previous methods. So how do we rewrite this as a polynomial? Well, polynomials don't have denominators, so why don't we go ahead and get rid of our denominators? Take a look at this real quick, and I notice we have two denominators. Luckily, they happen to be the same denominator in both pieces. So to get, say, this one to cancel, I'd have to multiply by an a minus 5. Of course, if I multiply by an a minus 5 on the left, I'm also going to have to multiply by an a minus 5 on the right. And conveniently enough, this denominator, since it was also an a minus 5, is going to cancel when I do the multiplication as well. So I'll be able to, with just multiplying both sides by a minus 5, get all of my denominators to cancel. So why don't we go ahead and do such things. The a minus 5 here cancels with the a minus 5 there, and I'm going to be left with just the a. Equals, what's it equal to? Well, I'm going to have to take and multiply a minus 5 times 3 and a minus 5 times 5 over a minus 5. 3 times a minus 5 gives me, change color, gives me a 3 times a minus 5 plus 5 over a minus 5 times a minus 5. The a minus 5 here is going to cancel with the a minus 5 there, right? And we'll just be left with a 5. Now, I want to be a little bit careful with canceling here. If I just write down, okay, that I canceled, if I happen to do this part first, you might look at this and say, okay, well, now what do I multiply the 3 by? Oh, I already canceled that. I don't have to do anything. That's not true, though, right? I need to multiply whatever this was by this piece and whatever this initially was by that same other piece. So even if I canceled it with one of the pieces here, I still need to take whatever used to be there before canceling it and multiply by this other piece, right? So we do that. Let's multiply through our 3 times a, 3 times negative 5, plus a 5. This all still equals a. I could go ahead and subtract a from both sides. If I subtract a from the left, I have 0. If I subtract a from the right, I have 2a. We could do this addition. Minus 15 plus 5 is negative 10. And now let's go ahead and add 10 to both sides. So on the right, the 10 cancels. On the left, I get a 10. Divide both sides by 2. 10 divided by 2 is 5. 2a divided by 2 is just a. So we get a equals 5. All right. Now this should be setting off some bells and whistles in your head. A equals 5 is very definitely the solution to this equation here. Right? If I plug in a equals 5, up here I'd have a 5 minus 5, that's a 0, times 3 is 0, plus 5. 5 on the right equals, on the left, a equals 5, 5, so I'd have 5 equals 5. This is a solution to this equation. Right? It is not a solution to our original equation. How do I know that? Well, I'm not allowed to plug in a equals 5 up here, right? If I did, I'd be dividing by 0. So a equals 5 is not in the domain of this equation, of either of the expressions that appear here. A equals 5 would give us an undefined result. So even though a equals 5 is a solution here, it's not a solution there. So I'm going to have to cross this out and say that this equation actually has no solution. If there was a solution to this equation, it would also have to be a solution to that equation. The only solution to this equation is a equals 5, and that solution is not in the domain of our original problem. So that's how I can confidently say there is no solution at all to this thing. Not just that I couldn't find it, right? I found what it could have been. The only possibility was there, and we had to throw out the only possibility. So no solution.